Hi, Dr. Pat here. We're looking at video number 3 for logistic functions. That model that's good for doing marketing, health spread of information, as well as spread of germs. Okay, so let's look at two versions of this model. We have our first version is using the exponential base e, and then the other model has exponential with any base that you want. So basically, just like we have different models, different versions of the exponential function, we can do this as well for our logistics because the part in the denominator has a part that's exponential. And of course, on the top, our upper limit, that's basically the ceiling of the logistics curve, applies both cases, whether you call it a letter C or a letter N, does not matter. It's all about what's the upper limit of our logistics curve. And so now let's take an example of making a model. Let's go and kind of go through the process for doing this. All right, so we're going to use this information that we've been given. The f has a limiting value of 11, and we have two data points that the graph will pass through. And so what we want to do is make a model. So I'm going to start with this version of the logistics curve. And so let's figure out what we have. Now, one of the pieces of information is the limiting value, and that is n equals 11. N is the ceiling for our function, and so automatically when we know the limiting value, the ceiling, the largest value that we can get towards, then basically we have that as our n value for the numerator of this function. So right away we can rewrite this function as y equals 11 over all that stuff in the denominator. And now we got to figure out the rest of that stuff. So we still have to figure out what the letter A, the variable A, not the variable A, but the letter A and the letter B here, what they stand for. And so then basically we'll use our data point 0, 1. So at time 0, we have a y value of 1. And so automatically that's going to be A equals 10. You might be wondering, whoa, where'd you get A equals 10? Well, let's take a look. When we plug in 0 for t here, that means b to the 0 power, that's going to be 1. So the only thing we have in the denominator then is going to be 1 plus a. And when we plug in that 1 for y, we're going to have 1 plus a equals this 1 over here. Let's cross multiply. Let's multiply both sides by 1 plus a. That brings it out of the denominator, and this is multiplying by 1. And so then we have 1 plus a equals 11. Subtract 1 from both sides, and that's how I get a equals 10. Then our next piece, and then we plug that 10 into it. And so then for our next piece, let's use the other data point. And so when I plug in 2 for the t value, 3 for the y, I will end up getting b equals 1.9365. That's approximately that much for our b value. And so then we can plug that b value in there, and we have our model. Now you might be asking yourself, dude, where'd you get the b? How did you turn out to be 1.93? What's going on here? Let me take a moment to show you. So how did I get that b value? How did we get that? And so let's kind of do that. So the first thing I do is I plug the data point in. And so we had 2 for our t value, and then we had 3 for our y value. So that's the first step. Next step, let's cross multiply. I'm going to bring this stuff up out of the denominator, and we're going to bring the 3 back over. And so that's what I do there. So nice multiplication both sides of the equation kind of situation. And then let's subtract 1 from both sides. Do note that when we subtract 1, we're going to have 11/3 minus 1. Recall that 1 is really 3/3. So 11/3 minus 3/3, and that's where I'm getting this 8/3. Okay, so it's just subtracting 1 from both sides to get rid of that 1. Our next step is we want to get rid of this 10. Let's divide both sides by that 10. And so 3 times the 10 down there, that's 30. And so we have our nice little fraction 8 over 30. Our next step is to get rid of this negative 2 power. The opposite of a negative 2 power is a negative 1/2 power. So by doing a negative 1/2 power to both sides, that will cancel out the negative 2 on the left-hand side, and of course we'll have negative 1/2 power on the right-hand side. Type that into a calculator, crunch it out, and basically we're ending up with a 1.9365 number. Just a note, when you do use the calculator, make sure that you have the parentheses for the 8 over 30. And also, when you do the power, the caret symbol, for the negative 1/2, make sure you're using parentheses for that. Or use negative zero point 0.5 if you want to make it easier. And so that's how I got that b value that we plugged into to our function there. And so that's how I created, without using the calculator, the regression model, just using the characteristics of the function. That's how I created the model for that case. Thanks and have a good day.